Got it.
Here we go. Woo! Number 5. How easy was it?
Easy.
Should have been easy if you know the formula for the theta polynomial, right?
Ooh, what you eating?
That's the reason why we get all jobs.
What is it?
Perfect bar.
You're perfect.
Thank you.
Oh my goodness. Here we go.
Perfect one.
Bye, Bono.
He's not going to watch this.
You guys get why it's P of 3, right?
Yes.
But why am I not doing P of 3? Oh, no, I am. Equals. I got it. Okay. What's the formula?
So it's 3. So F is 3. G of X.
3?
It's F of C. F of C, right?
3! G of 2.
Thank you.
Oh,
Times X minus 2.
Plus G double prime 2 times X minus 2 squared all over 2 factorial. Plus G triple prime 2 over 3 factorial. Times X minus 2
Times X minus 2.
Boss that.
No. Don't call for that. Don't you dare.
Wait, isn't that what they asked?
No, they gave us clues. You're plugging it in now.
They gave you clues. Don't you dare stop there.
Don't y'all dare. Now you plug, no, you have to plug in 3, you have to plug in -4, you have to plug in 7, you plug in -5.
Oh.
I baited you guys.
Doesn't mean that you have to plug in a lot. Okay, calm down. Calm down. Doesn't mean that you even have to simplify much. Learn to whisper. And not talk across the room. Okay. How we doing?
Yeah, we were good.
Now what? Use a third degree Taylor approximation of E. Wait. How are we supposed to use it if we haven't made it yet?
Make it.
So we have to make it. The x is going to be approximated by, don't worry, Corey, I'm coming, hold on. We need f of what? 0. Because it's centered by 0, right? Plus f prime of 0 times x minus 0. Plus f double prime of 0. How do I know when to stop? I could do this all day. Third degree.
What is it brought over? Factorial?
Okay. Corey, what's your question while I get this set up?
If you to the man in the first one, can you just box in the top over there?
No, sadly, because you haven't gotten it plugged in yet.
Okay.
But as soon as you plug it, you can stop. Same thing with long answer, you can stick it to the man with like sine of pi over 6, but don't you dare stop with like...
Sine of pi over 4.
What am I trying to say?
If you can plug it.
Don't stop with sine of x from pi over 4 to pi over 6. Stop at sine of pi over 6 minus sine of pi over 4.
Okay.
Does that make sense?
Look it up,
What's my f prime? Oh, this is nice. Do I even need to really find too many more derivatives?
No.
Because what's going to happen to all of them when I plug in zeros? All of them are going to be 1. So what's the third degree?
1.
Taylor polynomial.
1.
Plugging in 0, anything to the 0 is 1, so it's going to be 1 plus 1x plus 1 over 2 factorial x squared, or the way that we'll study it is x squared over 2 factorial. I'm coming, hold on.
Oh. I'm stupid.
Katrina.
What did you do? Why is it all 0?
The first derivative of everything is e to the x. I'm plugging in 0. And when you plug in 0, e to the 0 is always going to be 1. Okay, now hold on. I don't think we're done yet because we were just supposed to use this thing, right? So far we've only just found it. How do we use it? Take the limit. Okay. So the limit, as x goes to 0, of what? e to the x's third degree Taylor polynomial.
No.
Why does this make a difference?
It's an accurate number.
If you plug in here, right? If you plug in here, it's going to be 0 over 0 L'Hopital. You have to take the derivative in order to solve. That takes creativity. That takes human recognition. Ooh, human recognition. But if you are using a Taylor polynomial, an informed human recognition. If you're using a polynomial, couldn't you maybe figure this out without having to realize that it needs L'Hopital?
Oh, the
Yeah,
thing
see what I'm
is that
saying?
you can take it out and that.
The ones will cancel.
Yeah, and you can take out an X.
Well, besides that, can't you just say
Can you-
top wins regardless?
What? You take out what? What?
Then why can't you just say top wins?
We're not going to infinity. Sorry. That makes sense? We're going to 0, we're supposed to plug in 0.
Yeah.
I know, I was gonna say that.
There's an extra test history. Is it to like all these zeros?
I'm not saying that L'Hopital would have been wrong. What I'm saying is maybe you don't need human recognition to solve it. Interesting. Somebody had to program Wolfram Alpha to be able to do what it does. It's not a human solving it really fast. We're supposed to compare it to the actual. Guys, how would we find the actual? This is just an approximate, right?
Calculator.
Why are you using calculator? L'Hopital.
That's what you're told.
Guys, who do that?
What? Yeah, I missed. Why are they asking you if this surprised you or not?
Because they look really different.
Because it's the same, and usually they're off.
They look really different. The answer is the same, and we only used what to approximate E?
The third power.
The third degree Taylor polynomial. That's not very many terms, is it?
Nope.
It's not that great of an approximation for a very wide interval, but what is it for a smaller interval?
Pretty accurate.
A stinking accurate approximation. And question, hold on, where am I approaching? As x approaches what?
0.
Where is it centered at? 0. So doesn't it make sense it'll be perfect at 0? Or as you approach and pushing something close to 0? And see what's converging to, Gabby?
But so why did you plug in the entire piece of?
Because it said to use the third degree Taylor approximation of E. So we had to use E approximated with this when we solved that limit, so then this went and took the place of E. Does that make sense? That's how we used it.
So if it was centered at any other number other than 0, we wouldn't have gone.
It would not have been exact. It might have been very, 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 very close, so it still looked exact, but no. Now what? You see a second degree Taylor polynomial. So take your time, take your time. Some of you see it quickly, some of you won't. This is f being approximated by.
C's not. And there was still better. Oh wait, never mind.
Oh, the rest of them.
C's negative.
C's negative. B has to be plus.
Yeah.
B and A has to be what? Oh, no.
No, A is.
B
So
and
B doesn't have.
Looking at the graph,
A is
figure out
positive.
which one's.
A is positive, C is negative,
Because that's
A is
what.
positive, C is negative.
and but B is positive.
and B
That's
is
how
a
you know
50-50 chance.
She's negative.
Is negative because a parabola is what? X squared is a parabola.
Because if C is negative, then
Oh,
B is negative.
one and the fourth.
And then you can
C is negative.
So B is positive.
A is positive.
B has to be negative. Actually, it's not negative.
C is negative. C is negative.
If
You guys agree? Because of that point, because it's up, f of 0 is positive.
So A is positive.
Yeah, and the slope of that is B.
So B has to be negative. B is negative.
See how things get a little more exciting now that we know some Taylor polynomials?
Oh, that's saucy.
Justification? What I just wrote. Good? You guys see how I figured it out?
Nope.
Now to think about the Taylor polynomial equation, I thought about, wait, what would normally be in that spot, or that spot, or that spot? Hey, I'm looking at the first derivative, increasing, decreasing, looking at the second derivative, concave up, concave down, and I'm looking at the y values. Got it. B is the coefficient that came from the derivative at 0. At 0, my function is increasing. Hence the derivative has to be 0. And at 0, my function is concave down. Hence the second derivative must be negative. Interesting, huh? Okay. You want a picture of it? This is a great example.
Okay, never mind.
Ooh. Ooh. You guys know how we started with the, well, I didn't really call it Taylor polynomial, we kind of call it just a power series. But we used the power series for 1 over 1 minus x, which was, that's just a geometric series, a sub 1 over 1 minus r, so 1 and then plus x squared plus x cubed plus x to the 4th. And how we then said, hey, we could also do 1 over 1 plus x, or 1 over 1 minus 2x, right?
Yeah.
By plugging in, same thing here. So what if we already figured out that sine of x, you guys remember this from earlier examples? What if we figured out sine of x is?
1 plus
X minus x cubed over x. X fifth over 5 minus x seventh. Thank you.
Is it factorial? I haven't done that in too long. It was?
Are you sure?
We did the problem yesterday. Yes, we did.
Yeah, that's why I was having you guys refer to your notes, thank you for double checking. So we're good. What are we gonna do for sine of 2x?
I did not.
Plug in access to it.
It's in your face. Multiply everything by 2.
Yeah, that's it. It's in the phone.
Does that simplify though?
Sort of, you
If
can.
there was a multiple choice, maybe they'd simplify it. So that'd be 8x cubed, 8 over 6. Right? 2 to the 5th, isn't that going to end up being 32? And 32 over, wait, 120. Will stink. Can't I think of this as 32 all over 2, 3, 4, and 5? 5's not going to go in, 3's not going to go in, 2 and 4 is 8. 8 goes in 4 times. So 4/15ths.
Whoa.
Anyway, we got it? If it's a multiple choice, maybe. If it's a long answer, just leave it there. But there we go.
Would they ever combine that into a proper fraction? Or an improper fraction? With common denominator?
Not unless it, no. No, Taylor McLaren still keeps separate. I don't think I've seen it together. They might put it in a summation with an nth term,
Oh yeah.
but then you can just match it based on which one you choose. What are we gonna do for, cosine? Have we talked about cosine?
No.
Okay, so let's have a little bit of fun. Pause, there are 2 ways of doing it. One way is, we need to go ahead and think about f of 0 And then f prime, what's the derivative of cosine? We did this with sine yesterday, right? But couldn't we also say, how is cosine related to sine? How is cosine related to sine? Calculus, algebraically speaking.
Yes.
It's the derivative. Don't integrate because then it's going to be a negative, right? But it's the derivative. So couldn't I say that cosine is going to be the derivative of sine? So then, cosine, an easier way of thinking about it is just derive all the terms. What's the derivative of x? 1. What's the derivative of that guy? Bring down the 3. The 3 cancels with the 3. You have 2 factorial left. So it'd be x squared over 2 factorial. Bring down the 5. The 5 cancels. 4 factorial is left. So I have x to the 4th over 4 factorial. Do we see a pattern?
It's like that,
No.
but even.
It'd be really nice if maybe we could, memorize this thing. I really wish there was a way for us to remember that sine goes with odd and cosine goes with even.
Even and sod.
How about sine symmetry and cosine symmetry? Isn't sine an even function? No. Isn't sine an odd function and cosine an even function?
It's very odd, yes.
Anyway, sine is odd, goes with the odds. Cosine is even, goes with the evens. Anyway, what are we supposed to be doing?
Multiplied by x.
Multiplying by x. So wouldn't x cosine of x equal x minus x cubed over, isn't it just distribution, this?
Yeah.
Yes.
Well, that's easy. Oh, thank you. Question. So far, anytime I put p sub anything, it was always an approximate. Why am I suddenly putting equals?
Because it is, because you're going off of as, yeah.
I'm not stopping it at an nth degree, right? Okay. How about letter C? Who's E? We just saw him a second ago.
1 plus x plus x squared over 2 factorial plus
What? 2 or 2 factorial?
2 factorial.
I know, but for the purpose of the pattern, right? 2 factorial, right?
Plus x cubed over 3 factorial.
Okay, just checking. So I need to go ahead and plug in and multiply by 4? Can we do everything at the same time?
Yeah.
You guys cool like that? So plug in, well, whatever, times 4. Plug in 4x squared, right? Plug in
4x.
4x to the,
4.
not 16?
No.
Because 4 is being multiplied after we plug in. So it's x squared squared, x to the 4th, then times 4, all over 2 factorial. I'm coming, let me get one more. 4x squared cubed to the x to the 6th, all over 3 factorial. Okay, Katrina, go.
Why are the signs alternating?
Because with e to the x, we saw him just a second ago. All of his derivatives are positive. Whereas with sine and cosine, their derivatives alternate. Does that make sense? Could we simplify? Of course we could. Wouldn't we end up with 4 over 2 would just end up being 2, yeah? 4 over 6 would just end up being 2/3. It's hard to write 3 and I got confused. Anyway, that's it, I'm done. Done. Are we kind of getting how we can play with these?
Yes.
Can we form them if we ever forget them? Yes. Find the first derivative, second derivative, third derivative. Will we have AP questions where they force us to remember the definition of Taylor polynomials? Yes, like this guy. What would you do if you didn't remember the formula? Nothing. Well, nothing helpful anyway. Okay. This homework is going to be due in some senses tomorrow, but we're not grading tomorrow. We're zooming on into section 10.3, and you guys are going to kind of work on this on Friday. Sound good? Like work on showing up questions, working in groups, collaborating, etc. But we're not done yet.
Yay!
What does this look like? An example that we just did, right?
Yeah.
This is from our book. Does it look good?
Yeah.
Sure. You can do it?
Yeah.
Okay, let's keep going. How about this guy?
Oh, wait, what? Oh.
Seems good.
Ooh, ready, set, go.
Wait, don't you?
They give us the polynomial. Not quite.
Take the 10th first.
Pause. Just go. Find the first derivative at 0. What do we do?
I found it.
What is it?
Christian.
Not the first term.
Second term.
Plug in
There's
two.
like a second term, so if you said that you squared 0 plus
X to the 10th over 11 factorial.
What would it be?
isn't it 0 plus?
The formula. X to the n of 1 plus 1 factorial.
Good job.
Yeah, you give me that sense. One of them do that here. Yeah. Oh, yeah.
Some people cannot concentrate with constant noise. Okay, those people who are looking at the coefficients are thinking about the following. F of 0 must have been, F prime of 0 must have been, F double prime of 0 must have been. So check out the x, he's the first degree x, right? And we're thinking about f of just x, not x squared, not x cubed. So therefore, cool, f prime came from right here. And what coefficient is right here? You can say 1/2, but 1 over 2 factorial is sufficient. And how on earth am I going to do the 10th derivative without continuing this pattern to the 10th? What, Jason? Look at the general form and or the general idea and say the 10th power of x is going to get me 1 over 11 factorial. Some of you could have figured that out just from thinking of the general pattern and saying, well, if that's the first derivative, and that's the second, and that's the third, well, then that must be the 10th. Did we actually have to find those derivatives of this? No. Could we have actually derived it? And said, hey, the derivative of this guy, who is f prime of x? Isn't it going to be 0 plus 1 over 2 factorial plus 2 over 3 factorial x plus 3x squared over 4 factorial? Wait, what happens to all these guys? I don't get it. Oh, it's f prime of who? Plug in 0 and all that cancels, and what do you got? But was it a lot easier just to go ahead and look at the pattern with the formula? And the answer is
Yes.
hopefully yes. Okay, that was A. That's not too bad, hopefully, but what about B? Yes, B's get a lot harder, depending on how tricky it is.
X plus x squared over 2 factorial plus x cubed over 3 factorial plus x
Okay. So Corey, what were you saying? What were you doing?
Just multiplying everything by x.
Good.
Thanks.
It says write the first 3, make sure you're following the instructions, the first 3 non-zero terms and the general term. Right? So that would be,
We do x.
you could do it a few different ways, but couldn't you do n? No.
That would be x
X
plus
plus
Yeah. Sorry, I was thinking of derivative based on another homework problem from x to the n times x all over m plus 1 factorial. Some of you realize, hey, if you're just multiplying that guy by an x, some of you were like, oh, let's just make it x to the n plus 1. Both ways are fine. Why is it super important that we put a plus dot dot dot, even though they didn't say to do so?
There's even more.
No. If I didn't write that, I'd be wrong. Why?
Because then you're saying that's the final answer.
I would need to write an approximate instead. Right?
Okay.
Number letter C? You're welcome. Number letter C. Nope, sign alternates, so is cosine.
E. Oh, E.
Yes. What other function would have an f prime of 0, f double prime of 0, f triple prime of 0, f quadruple prime of 0, all equaling 1?
E.
Hey, is it kind of important to know the basic power series, Taylor Maclaurin's, especially Maclaurin's for some of these special guys?
Is it type types?
Nope.
Where do you get the?
Isn't g of x times, oh, hold on, I can't even see the whole problem. I can't see the whole problem, I apologize. Did I write this wrong? Is this not g of x?
That is G of X.
Ah, we're not asking who f is in relationship to e of x, we're asking who g is.
Yeah. So
Doesn't
E to the X times X.
doesn't e to the x have a 1?
So we need multiply.
Because it's 1 plus
What is e to the x?
1 plus X
Ah.
plus.
Yeah.
Because you need.
Oh, because you gotta get rid of the first person term would be x.
So one more time, is it important that we have these numbers?
Yeah. Yeah, we already got that. Yeah, so.
Pause in your notes.
Notes.
Why is it going the wrong way? Go. Write it down.
I started doing it. Yeah, I started doing that.
Where are we at?
26.
Have we dealt with all of these guys? We kind of have.
We did
The one that's least familiar is number 5. You started with him, because isn't he just a basic geometric series, times x times x times x? These two alternate, cosine is an even, sine is an odd. E to the x, his derivative is the exact same, so starting at 1 and then moving on. ln of x plus 1, let's just say if it was any other ln, it would not be quite so pretty. So hence why they use that one.
There's another one where one of
You guys got them all?
No.
Oh, okay. Go, Santa.
There's another one in the book where it's 1 over x plus x, or 1 plus x. And I think isn't the sign just flip? Can you do that?
So then the idea is, because even though these are the most basic ones, as Noah said, he said in the book there was one extra one, from these, couldn't they also ask you for, without you having to derive the entire thing, aka come up with the entire thing by taking all the different power derivatives and plugging them in, couldn't you pretty easily also get 1 over 1 minus x squared?
Yeah.
How, just square it all?
No.
Don't square a polynomial, that's disgusting.
You replace the x with...
Can't you say the derivative of this is going to be negative 1 over, actually positive 1 over 1 minus x squared? Just derive it. Couldn't we also get ln of 1 minus x by integrating? Couldn't we also get 1 over 1 plus x by deriving? Couldn't we also get 1 over 1 plus x by plugging in a negative x and negative x and negative x, which only changes alternating the signs? So we can play with, I think these are the most basic, the most fundamental, that we ultimately need to get memorized. Now, hold on, we didn't totally finish. Oh, an FRQ, that's fun. Anyway, what about this guy? It's the accumulator function, but what's cool? They're actually using the accumulator function to deal with Maclaurin series. BC, one step above.
2 over 1 minus x squared.
What do I do?
You have to put the thing in the integration.
I need the Maclaurin series, right? P sub 4, I could just say P sub n if I wanted to. P sub n, the nth degree Taylor polynomial. Or Maclaurin polynomial centered at 0. But wouldn't I have to take f prime, f double prime, f triple prime, f quadruple prime? Alright, we'll get started this homework. Doesn't have to be totally done, so you have a little bit of a work day, but that work day, if I were you, I would only have my questions to work on. If you try to do all the homeworks in that one period, that's not a good idea. So work on it. I'll see you guys tomorrow. Maybe I'll answer 1 or 2 questions if we totally get stuck.